Again, thank you very much for having me here. Having our it's a great privilege and a great honor to be able to present at this event. Due to the circumstances, we're doing this virtually, but next year, for sure, next year we're gonna go on in person. And thank you everyone that's watching this. Thank you for everyone that's watching this as well. Guys, I thought very much about the title of these presentation, and it's called SQL Server 2019 Top Features That Every DBA Should Know. So I focus this mainly on DBAs per se. We know that the top feature or the game changer for SQL Server 2019 is the big data clusters. But there are lots of features, of other features other than the big data cluster itself that are worth noticing. Lots of other features that are going to make the DBA lives a lot easier, very much easier. I also thought of naming this presentation beyond big data clusters or something like that, but I thought it would be better to simply leave that as every DBA should know, all the features that every DBA should know. I'm not going to dive in very much into the big data clusters itself here, as you're going to see, but we'll talk very briefly about it. So this is me. My name is Marcelo. Feel absolutely free, and all my contacts are there. Feel absolutely free to contact me, to send me an email message, an instant message in Facebook, Twitter. It's missing Instagram there, but anyway, I have about 15 years of experience as DBA. I have always been a SQL Server DBA, and I now work for a database consultant group called Pythian. This is a company based in Canada that relies on remote work mostly, and they have all kinds of we have all kinds of database or data platform solutions. So if you need a hand, don't hesitate to contact us as well. I also hold a couple of certifications, Microsoft and also Oracle, but I'm not currently an Oracle DBA. I just know the technology, so I can say bad things about it and convince everyone to come to the Microsoft area. I'm just joking. I'm just teasing. I also like Oracle, the Oracle technology very much. And all my contacts are there. Feel absolutely free to get in touch. Okay, without further ado, let's see what we're going to talk and discuss about today. We're gonna see the new platform for SQL Server 2019 today, and we're going to dive into the features itself, or at least the features that are going to make our lives, DBA's lives, much easier. Table variable deferred compilation, memory optimized TempDB metadata, TDE Pause and Resume, some sub features for mission critical availability, and the platform of choice as well, and how you can leverage SQL Server uses in any platform that you'd like. And we're also going to see some references by the end, and also data virtualization as well. Let's hope that we have time for that. So that's the very first slide, or a very common slide that we see from Microsoft when they were planning the release for SQL Server 2019. This is, I guess, 1.5 years or 2 years old, something like that, and it shows how SQL Server, how Microsoft really changes. I don't work for Microsoft, okay? I'm not selling anything here. And this slide is, in one slide, it shows how comprehensive SQL Server is, and how they're leveraging pretty much everything data platform or data-wise within a company. You can write from within SQL Server. You can write T-SQL code, and you can write any of the Spark related languages. there's a machine learning service running with along with SQL Server as well. You can choose the platform that you'd like to run your SQL Server. If you want to run it on Windows, that's fine. If you want to run it in Docker, that's fine. If you want to run it in Linux, that's fine. And it's very easy, very quick and straightforward to install a SQL Server instance in Linux. Guys, I'm switching my head here because I'm looking at the other screen. Okay, I'm not deviating attention or anything. And we also have we also see for SQL Server industry leading performance through a couple of third-party benchmarks, independent benchmark companies. We could see, or we can infer, and we can see that SQL Server is one of the top performing relational database engines in the market. It is also the most secure over even more than 8 years. Microsoft really invests heavily in security features and security enhancements over the years. You can see and you can realize their efforts in that, releasing with every version, releasing a new feature, security feature. Back in the SQL Server 2016, we had always encrypted, where you don't have only data encrypted at rest. You have data encrypted at transit as well, and the encryption for that data is not on the hands of the DBA. That the encryption keys lies within the application. That's pretty amazing. That's pretty fantastic. And you also have with SQL Server 2019, you have the same technology with enclaves, which is a new feature as well. And you also have insights and reports in minutes, literally minutes, within the same range of SQL Server. You can install Power BI or Power BI reporting services, or even report servers, the native report server, and you can create, or you can infer from your data, from the intelligence that you have over your data. You can create great reports for all of your users. And when I say that you have all these comprehensive features within one big pack, you have that at literally 1/10 of the cost of Oracle. And that's not a marketing model here. It really is. When you buy SQL Server Enterprise Edition, you have pretty much everything. When you buy I'm also on Oracle DBA, so I have to say that. When you buy Oracle Enterprise Edition and I want to use Oracle Real Application Cluster, I need to buy for the Real Application Cluster feature as well. I need to buy the extra features as I want to use them, even if I am running Enterprise Edition for Oracle. So that's a very valid and key point here. And every feature that you have on premises for SQL Server, you have on Microsoft's public cloud, Azure as well. So the communication and the migration between those two is pretty much seamless and continuous. Okay, that's pretty much a slide that I have to talk about, or to show how the big data cluster works, and that's the big game changer for SQL Server. I'm not going to demonstrate it, but I'm going to pretty much show it very quickly. You have a SQL Server master instance here that controls every kind of connection that you receive, and this SQL Server master instance is going to create compute pools, create and destroy compute pools as they are needed. How so, Marcelo? Well, with big data, we know that we're dealing with lots of data, and you have the SQL Server master instance is going to rely on a tool that's called Kubernetes to create more SQL Server compute nodes that are within SQL Server Docker images that are within Docker images. And with that, you also don't have to pull your data from your external data source inside your SQL Server as well. You can use another feature called Polybase to leverage data virtualization. So you can connect to another SQL Server instance or instances. You can connect to any other Oracle, MongoDB, Teradata, Cosmos DB, any other data source that is supported by Microsoft, and you can query that data in place. So you don't have to pull that data from the source and bring it to the destination, to origin. You don't have to bring that data into your computing nodes as well. So with that, you also don't need to worry about ETL anymore. So that's a very nice feature as well. I have been using that around. We got a couple of customers that are using that as well. And with that, I like to think that with that feature, I like to think that SQL Server wants to, or Microsoft wants to be a central hub. Microsoft wants to create SQL Server to be a central hub for data processing. Think of it as a universal remote controller. Here at my house, I have a PlayStation 5, I have a home theater, I have a cable setup box, I have a TV, and I have to use one remote control for each of these individual devices. With the idea of SQL Server, as I see it, is let's centralize everything in one big place, and that's it. I'm not going to dive into that any longer. I want to show you the good stuff. This is good as well, but I want to show you the good DBA stuff. But here are a few great resources that you can find. The first two are in Portuguese because I'm from Brazil, São Paulo. So a friend of ours, Luis Gaetti, talks a lot about this feature, Big Data Cluster. He's a real expert in this feature, and he even presented a webcast for us. I'm gonna ask him to do this webcast in English as well. So we're gonna have both versions. SQL workshops, which is it's a group work from Bob Ward and some Microsoft folks as well, and they're doing great. They're doing a terrific job creating great resources for studying and for practicing. That's free. For now, it's pretty much free, and all of the new features, all of the new SQL Server features are here as well. There are more in the references ahead. Now, let's get into the good stuff here. Okay, table variable deferred compilation. From when SQL Server started having table variables, you know, not the temporary table, but the table variable itself. Temporary table is the one with a hashtag. Remember, you guys remember that. Table variable is the one with the @ in front of it. Okay. SQL Server started accepting this variable in SQL Server 2005, if I'm not mistaken. Yes, 2005. You couldn't do that with 2000, if I'm not mistaken. Anyway, there's up until SQL Server 2017, there was an issue, a potential issue. I don't like to say there was a problem. I like to say there was a potential problem with using the table variable. That problem is that the query processor from SQL Server always considers that there's only one row in that table variable. So there are pretty much no statistics for this object. SQL Server always guessed or considered that a table variable within a procedure is going to have one row. Try to imagine if a table variable actually has one row, 2 rows, 5 rows, 10 rows. It's still okay. You might be good performance-wise with a procedure that uses it, but try to imagine a procedure that has like millions or hundreds of thousands of rows. Try to imagine the query plan that's going to be generating by estimating that this table has only one row, this object has only one row, and whereas in fact it has like millions of rows. It's going to be bad. It's going to be a real bad execution plan. And by estimating it properly, I can SQL Server can create a proper execution plan. So by creating a proper execution plan, you're going to have better performance. Before SQL Server 2019, what would we do? I normally change that to I normally ask or recommend changing those table variables to temporary tables, because temporary tables have they do have statistics, so they're a bit better. They're a bit better in that matter. Okay, it makes more sense to use them. Anyway, let's dive into the demo here. Give me one quick second. Let me see if I have everything open. I hope that you can see my management studio. Okay, I'm going to pull my script real quick here. Okay. Okay, just so you know, I have a SQL Server 2019 instance running here. That's pretty much what I have, and I have Polybase here as well. But those are manually those are stopped for now. Okay, so oops, sorry. I'm going to execute create procedure here, and what this procedure is going to do is it's going to simply create a table variable. Okay, very straightforward. It's going to insert a few rows from an existing table called fact order history. Okay, and afterwards, after that table is populated, we're going to do a join with the order history and the order history extended. Okay, I think nothing new here, nothing new to see here. It's what we expect, pretty much. Okay, so I'm going to clear my cache, my procedure cache here, and I'm going to change my compat level to 130. It's now running as SQL Server 2016. Okay, right. Okay, so I'm going to run it. I'm not going to execute it 3 times. Sorry, I'm going to execute it only once, and we're going to wait. Sorry, it says minutes, but it's seconds here. Sorry. It's going to take a while. It's executing, so it's pretty much. Oh, sorry, forgot to include the actual plan. Apologies for that. There you go. I want to see the actual execution plan to see the difference between the estimation of rows and the actual number of rows that were read. Okay. While it executes, I'm gonna go back to my PowerPoint slide, and then I'm going to okay, and then I'm going to talk about another feature. Let's dive into the other feature. Right. While it executes there. Okay. It's not done yet. 40 seconds and it's not done. Okay. Okay. Memory optimizes TempDB metadata. Interesting. You probably that's also to solve another classic DBA problem. I've always heard, ever since SQL Server 2008, I've always read that it's recommended to have an X number of TempDB data files, and all those data files must have the same sizing, and they must grow by the same increment, and they must grow evenly and equally. When one data file grows, all the others must grow as well. You can have, if you have four CPUs, create 4 TempDB files. Go to the limit of 8. That's what the best practices by the book says. I'm not against it, but I don't always execute it. I only follow this best practice by the book when I have, or when I see an actual TempDB contention problem. And when does the contention problem happens? Well, it says metadata. Metadata is pretty much the catalog. You can hurt, and I'm quoting that here, you can hurt the temp data catalog when you can hurt performance when you are simply executing lots of create temporary table. I'm creating lots of temporary tables at the same time. We have a bunch of connections creating lots of temporary tables at the very same time, and it's creating what we call TempDB contention, TempDB page file, PFS, GAM, or system tables, pages contention. And in order to avoid it, what would we do in the past? We would create the number of an even number of TempDB files, TempDB data files, where this number is the same as your CPU count, and you would have to enable, before SQL Server 2016, you would have to enable trace flags 11.17 and 11.18, so that all the data files would grow evenly, because there's an algorithm there called proportional fill that only works if they grow evenly. Okay. But it's TempDB. It's ephemeral. Whenever we restart SQL Server, it gets restarted. It gets destroyed and restarted again. Why the heck do I need to persist metadata for this if this is ephemeral? If this is going to go away if I restart SQL Server? Let's use, remember Hackathon? Remember SQL Server? Remember SQL Server 2014, where Microsoft developed the Hackathon feature, the in-memory optimized tables? Yes, let's use that. The idea was to use that within TempDB to avoid the system contention that we see all the time. We see mostly, not all the time, but we see quite some times. Okay. That's great. Let's use it then. Careful, that's enterprise only, of course. And there's one small catch. If you're using column store in temporary tables, it's not gonna work. Your code might break. You need to either not use the TempDB metadata optimized, or not use column stores anymore in temporary tables. Okay. Let me get back to the demo. All right. So it executed in 41 seconds. Remember, this is legacy mode. This is 130. Let's go to the execution plan. Okay, batch wise, it already says like that the table insert in the order variable is 100% of the cost, and it's obviously not. As you can see here, you have table scan in the order table variable, and you have an index seek in the order history extended where I'm doing the join. Pretty straightforward. However, if I hover my mouse here and I zoom in to that, I'm going to see that the estimated numbers of rows to be read is 1. Like I told you guys, it's simple. It's very simple. A SQL Server is going to always estimate, or is going to always assume that you have only 1 row in a table variable. That's it. Now the actual number of rows read is 3 million. 3.7 million, sorry, 3.7 million. That's a big difference. If SQL Server would have estimated something closer to this number, something closer to this number, this would have been a lot quicker. This took 41 seconds. Okay, now let's go back to Management Studio here, and I'm going to make sure that now I'm using compat level 150. Now I'm native to the instance that I'm running. Okay. I clear the cache. Whoa, that was quicker. Again, 11 seconds. Oh, someone is asking to make it bigger. I guess you're talking about the screen size, right? Yes, I'll make sure I zoom all the time. Okay, execution plan. Now you can see the difference. You can see the difference here. Now the insert is like 11% of the batch, and now you have 89% taking place here. I'm not going to discuss the missing index here, but now you do have a hash match. In the previous you had a nested loop, if I'm not mistaken. So now you have a hash match, and you have a table scan here. Cool. Now let's see the estimates and the actual number of rows read here. Okay, so on the table, in the table variable, okay, orders, at orders, I have an estimation of rows of 3.7 millions, and I have an actual number of rows of 3.7 millions. That is way better. That is a way better an estimation. That's why it took like 11 seconds, which is four times quicker. So just by changing the compatibility level to the native instance, 2019, it runs faster. It ran a lot faster, and that's just the table variable deferred compilation is just a small subpart of a bigger feature family called intelligent query processor, intelligent database, something like that. Anyway, okay, and now let's go, since I'm already here, let's go to the memory optimized TempDB metadata. I'm gonna go back here to Azure Data Studio, okay, and I'm going to connect to my local 2019. If you're not using Azure Data Studio, make sure you start using it, or at least getting familiar with it. It doesn't do everything that SQL Server Azure Data Studio doesn't do everything that Management Studio does, but it does other cool features. It does other cool stuff as well, like notebooks. Now here, just zooming in and explaining to you guys. Here I am shutting off the feature TempDB metadata. Okay, that's pretty much what I'm doing here. This feature is probably on right now, so I'm gonna have to value in use. I'm gonna have to go ahead and restart my instance, my local instance here. This is not dynamically. This is not dynamically enabled. I need to restart the instance whenever I enable or disable this. Okay, just stopping and restarting the instance, very quick. Right. So if I hit select again, okay, now as of right now, I don't have the TempDB metadata memory optimized enabled. Okay, this feature is right now disabled. Okay, I'm gonna go ahead now and create a temp stress DB, which is a dummy DB with a very simple procedure that simply creates temporary tables. That's very simple. And I'm going to the key here is to stress execute this. I'm gonna run this in O stress. You're going to see lots of connections connecting to this instance and running at the same time this query, like creating temporary tables all the time. Okay. I'm gonna type in the command here in my command prompt. O stress minus Q proc hurt tempdb. Let's see if I can make it bigger by default. Give me a moment here, please. Font. Hopefully that's better now. temp stress db minus s dot. All right. What I have here is I'm gonna run ostress, and ostress, please execute this procedure from this database, simulating that I have 50 users running this at the same time, and all of these connections, all of these users, they're going to run this this query 1,000 times. Okay. Okay, it started. So I'm actually right now I'm stressing my tempdb. Let's look at a little more detail here. Let's see what's going on. Okay, first query, I'm running a select joining a couple of DMVs, but the main DMV here is exec requests. So I am pulling that from the requests that are actually running right now, and you can see database ID. Sorry, you can see database ID 2, which is tempdb, and you have a simple data page being used, being accessed right now, and I'm writing in it by creating a temporary table, right? Now, if I execute sp who's active, remember that proc from Adam mechanic. Yeah, if you never download it, go ahead and download it, please. Anyway, so I have the procedure running here, exec proc hurt tempdb, and I have a pagelet contention, the pagelet contention in tempdb in the very first page here. Okay, pagelet contention, right? Okay. Now I'm gonna go ahead and cancel that. Just hitting Control C here, just canceling that, right? Not stressing anything anymore. Right. Now I'm gonna go ahead and enable the tempdb metadata. Like I told you guys before, I need to restart the instance. And it's very interesting when you run it. When you enable this feature, you can see a trace flag running, and you can't disable this trace flag by disabling a trace flag. You have to disable the feature itself. It's very curious. Anyway, but it's just for the sake of curiosity. So if I read my my error log right now, after I started my instance, I'm gonna see that I have the feature, I have the name of the feature here already. So it actually started. Perfect. I'm gonna run the very same stress, the very same query stress item. Query, sorry, here. Okay, very same. Okay, it's running. Let's execute this. Let's see if we can see some activity. No activity. No stress at all. Azure Data Studio is not quick enough to grab this. Yeah, I wanted it to show something, but it's not showing. It's not gonna show anything, at least on who's active. Let me go to Management Studio. Oops, sorry, forgot to. Okay, there you go. I think it's done. Yeah, it's done. Let me run it again. So you do have 2 sessions here. Exec proc hurt, 3 sessions running running the hurt procedure. Actually 4 sessions, but you don't see a block, and you don't see wait info as well. Remember that when we didn't activate that feature, you had the wait there. There's no wait here. Nice. Okay, so I'm going to execute that again, and it's not gonna show me anything anymore. But this query, the below query, shows me all the objects that are memory optimized objects. So they're actually using the hackathon or the in-memory feature. Okay, all of the metadata objects, pretty much most of the metadata objects here. Okay, perfect. Let me get back to my PowerPoint presentation here. Okay, another nice enhancement to a new feature, to an existing feature, TDE Pause and Resume. And that's very interesting because when you enable TDE, transparent database encryption, you can have performance problems when SQL Server is running the scan phase to make sure that your data is being encrypted properly. Now, the ability to pause and resume is great because it means that in big environments where you have huge workloads and where you have low LTP running all the time, you can simply pause it during the day and then you can resume it later. But one nice addition to that is Microsoft released TDE now. Allows the customers to use TDE even in standard edition. We did a migration a month ago, 2 months ago. We did a migration of a customer that wasn't still GDPR compliant. they didn't have TDE because they were using SQL Server 2014 standard edition, and they didn't want to pay for the enterprise edition because they didn't need to use the enterprise edition itself. So they said, okay, you have green light, we have a test environment here, let's test our application in 2019, and it's running 2019 without problems. Okay, now let's migrate it. It's migrated. So we did an in-place upgrade of the SQL Server, of the existing SQL Server instance. I prefer out of place, but anyway, and it's running perfectly fine. And now they have TDE as well. Oh, and if you're enabling TDE, don't lose the encryption keys, please. Don't. Okay. Talking about mission critical availability, we have the complete feature for resumable index operations in SQL Server 2017. You could pause an alter index rebuild. For example, you could pause that operation. Now you can pause the create index as well in SQL Server 2019. Some availability group enhancements. Well, in 2017, you could create an availability group without a Windows cluster, because you could now use SQL Server 2017 in Linux, which is great. But in SQL Server 2019, you now can have 9 availability replicas, and you also can have 5 synchronous replicas as well, which is fantastic. It's a great add-on for big, highly critical environments as well. And my personal favorite feature of all, the SQL Server 2019 for DBAs, accelerated database recovery. That's by far the best feature of all time. Well, not of all times, but it's a very nice feature. If anyone here that's a DBA or that has some DBA experience has run into the issue of the never-ending recovery. There's a very big transaction running, going on, and someone says, oh, the system is slow. Okay, the system is slow. The transaction is lost, and the original connection is lost, and the transaction is stuck, and it's running. Okay, let's kill this session. Okay, session killed. Then you run sp who's active again. It says killed / rollback. You get chills on your spine, literally, because the system is not getting quicker. Then someone either has the idea, or someone already goes and simply do that. Someone restarts the instance. The SQL Server instance starts to respond again, but the database is in recovery. The database, it's by design. It's like that by design. It needs to leave a consistent state, and it needs to start in a consistent state. You can't access your database in the middle of it. There's no way that's going to happen. Okay. Okay, this is about the index operation, and this is due to the database, to the classic database recovery. That's how SQL Server is by design, and that's the method that has been running for 25 years, pretty much. 25 years ish, something like that. 25 years. That's a lot of time. Anyway, with the regular recovery, and that's how pretty much Oracle works. That's how MySQL works. That's how every relational database engine works, pretty much. What do we have here when we are starting a SQL Server instance? SQL Server needs to do that, those three phases to all of the databases that are in that instance. Okay, phase one is analysis. Okay, let's read the transaction log, the LDF. Let's read the transaction log to see the last checkpoint and the oldest uncommitted transaction, or where is the beginning of that that list of transactions that I need to redo, or that I need to actually undo. Then during the second phase, SQL Server is going to redo what has been committed, or what is an actual transaction, completed transaction, begin tran commit. Okay, that's the second phase. Third phase is the undo. Let's remove all the transactions that are either rolled back, has the rollback, the corresponding rollback to the begin transaction, or to all open transactions, begin transaction and no commit, or no rollback, or no commit, or whatever, no closing keyword. So it has to do all the it has to undo everything. That takes time, depending on the amount of transactions that you have to that you have loaded, the amount of entries that you have inside the transaction log file, depending on the amount of virtual log files that you have inside your log file. It depends on lots of factors, lots of configurations. But if your database was non-responsive before, it's still going to be non-responsive after you restarted the instance, and that's a big problem. Okay, now enter SQL Server 2019 accelerated database recovery. With accelerated database recovery, you have a secondary log. Secondary log. It's not a new log file. Okay, it's still the same file, the same LDF, but you have something very similar to the read committed snapshot functionality, versioning. When you enable ADR, when you enable accelerated database recovery, you enable versioning in your database as well. But the versioning is stored within the database, unlike read committed snapshot isolation. You're not version storing your data in TempDB. You're version storing your data within your database, which makes more sense if you ask me. So in the log itself, in the transaction log, you have very small bits and parts of the transactions, and the data itself is already within the data. It's already within SQL Server doesn't have to remove the data, doesn't have to actually remove and redo the whole thing, the whole portion. First phase is the same. SQL Server is going to read the log, and it's going to see where is my last checkpoint, where my last checkpoint did take place, and where is my oldest uncommitted transaction. But SQL Server only switches very quickly from the data that was to the data that is right now, or vice versa. It depends on the phase. On the redo phase, it's going to simply check the secondary log for a newer data, and that's it. Very quick, very easy. Now, like we used to say, or we like to say in Portuguese, that here in Brazil, we like to say that there's no free lunch. When you enable it, you're going to have a small disk cost, given that you're storing more data now, and you're going to have a CPU cost, a CPU overhead as well. So thread carefully and test when you're enabling it. when you are actually enabling it. I enabled it in a couple of SQL Server 2019 instances that I recently migrated, because the customers that are using it, they can leverage from it, and it has been hurtful in the past. So make sure that you have this, make sure that you have a CPU to run this, to enable it. If you don't address these two computing factors first. Now let's take a look at that in play. I do have Management Studio here. I have two demos for ADR. I'm just going to do one. That's very straightforward. I'm going to zoom in a bit okay. I have two databases here. I'm going to drop them. Give me a moment here. And I'm going to recreate them. One of them is called, let me zoom in for you guys. One of them is called Old Reco, and another one is called New Reco. New Reco has accelerated database recovery turned on. Oh, I forgot to tell you guys, this is an enterprise only feature as well. Okay, and it's not enabled by default. You need to jump into your instance, your Management Studio, and enable it. Okay, so I'm gonna have 3 sessions here. In the first session, I'm going to run a big select into. I'm going to run the exact same query in session number 2, and in session number 3, I'm going to kill SQL Server. Okay, with a wait of 1 minute is more than enough for us here. It's gonna do a shutdown with no wait. Let's execute this and wait for it to happen. New reco and old reco. Okay, both sessions running at the same time. When we reach 1 minute, it's going to kill my instance. All right. One of them has the ADR feature enabled, the other does not. Okay. I'm gonna go back to the slides, and in 30 seconds we get back here. Okay. Okay. So also with SQL Server 2019, one of the top features of actually SQL Server 2017 was now you can run it on Linux. With SQL Server 2019, you have more capabilities and more features to run your SQL Server on Linux. Now you have distributed transactions, you have replication, all kinds of replication running. You also have machine learning services running as well, and you also have Polybase, which is what we use for data virtualization, which I'm going to talk in a bit. You can choose between those the three main distros for running SQL Server on Linux: Red Hat, Ubuntu, and SUSE. No one is going to tell you which one is better. You're going to choose the one that you prefer. You can also run SQL Server in Docker, from Docker images, and also obviously from Windows. A cool fact, an interesting fact that I had when I was presenting something about SQL Server 2017 in SQL Saturday New York last year. An attendee was talking to me, and he said, Marcelo, do you have any experience in that? Yes, I do. And he said, I have to migrate to Linux. I have to actually migrate to Linux. Can I do that now? I said, okay, it depends on the external features that you're using from SQL Server. If you only run the actual query engine, if you actually run only the SQL Server engine, you should be fine with SQL Server 2017. No, I also use replication. Then go for SQL Server 2019. But just out of curiosity, why are you migrating to Linux? You're not happy with Windows anymore? No, I'm happy with Windows, but Microsoft is charging a bit more for the licenses. for the Windows licenses, not for SQL Server licenses. In order to renew the support, I need to pay. I don't know the price. I need to pay an extra thousands of dollars, and that's why we're testing. We're extensively testing and leveraging and considering Linux, Ubuntu. Okay, that's a cool case. I hope that everything worked fine. Anyway, we have an instance dropped here. Let's get back to okay. Okay, let's see. I'm going to zoom in, okay, guys? Just a moment. Okay. Okay, we have recovery completed for new record, which is using the feature, and it took 6 seconds. Okay, recovery of old record is 0% and it's starting. Okay, let's rerun it. I think now it's complete. Yeah, it's complete. So recovery completed for new record is 6 seconds in total. Recovery for old record 43 seconds. So I pretty much ran exactly the same thing in both databases, which were recently created. They were dropped and created, the databases. So they were pretty much the same size. And you see that with leveraging advanced database recovery, we have a time frame of 6 seconds for recovery, and we have 43 seconds for the classic recovery per se. Fantastic, great difference. It's really a great feature. Larry, how much time do I have left? I think I don't have time left, right?
We're right at the end, yeah. We're at 4:30 now.
Okay, just I promise that it's only this last slide.
Okay.
Okay, and the very last feature that I'd like to discuss is data virtualization. Back in SQL Server 2016, we had Polybase. Polybase leverages something very similar to linked server, where you can query external data, and that's where the similarities end. Polybase is way more robust than linked servers. But in SQL Server 2016, you could only use Polybase with Hadoop and blob storage. That's pretty much it. That was as much data virtualization that you could do. And that was very useful to not move data from Hadoop into SQL Server. You could query your data where it was, your external data where it was. And now with SQL Server 2019, you have more drivers, more relational database engines drivers, NoSQL drivers, big data drivers. You have lots of external drivers within the SQL Server engine, within the Polybase engine, sorry. And this is all native. Those are all natives. I already tested with Cloudera, MongoDB, Cosmos DB, which works natively, obviously. Oracle, you can query SQL Server. And the main idea here is to have external tables, which are pretty much the frames of actual tables within your SQL Server engine and within your SQL Server instance, sorry. And from these external tables, you can query your data directly from where it is by using Polybase. it's the gateway, it's the remote controller metaphor that I used before. That is at show here. I don't have to transfer my data in and out. Okay, data can sit where it lives, and I can query it seamlessly from where I am. Okay, and here are a few references that I used to create this PowerPoint presentation. Great thanks to Bob Ward and his books as well. They have been really helpful in this journey. And that's pretty much it. Those are my contacts. Thank you very much. Please make sure you add me to LinkedIn and etc. And I'm available for questions. Laurie, I'm not sure if there are any.
No, not at this time. There's been no questions.
Perfect.
Great presentation, Marcelo. I really enjoyed it. Very good.
Thank you. Appreciate it. I think it's
yeah. We do have some thanks to a great session. So yeah, I was just trying to get that information. Oh, they're telling me raffle is going to be done offline because yeah, our schedule has them going to a room, so I'm not sure.
Okay.
But they just pinged me, said it'll be done offline. But thank you everyone for joining us today. Oh, Mikhail, will we get the presentation slides, Marcelo, and any of your demos?
It's in the, I'm going to zip it and I'm going to put it in the schedule, in the SQL Server, in the SQL Saturday schedule.
Right, so yeah, let me grab that link real fast and I'll put it in that. I can tell you exactly. Shoot, if I could type, let's see. Should I have it up here on a different, here we go. If you go to the SQL Saturday and go to our schedule, you'll see that there's already actually some sessions that have been uploaded there. So you'll go to this link. There you go. And you'll see them there. And you can there's a download link. So that's great. Thank you so much for that. Yeah.
I think you're not, sorry, I think you're not presenting. Sorry, let me.
Yeah, no.
Let me pull that. It's this site, right? Schedule.
Yes.
SQL Saturday /978 sessions schedule, and that's it. You're going to find it. You're going to find the presentations here.
Yep, downloads. Perfect. Thank you for sharing that.
No worries. No worries. I thank you for the opportunity. Thank you very much, Laurie, for making this a great event.
Oh, great. I'm glad you enjoyed it. Hope everyone did. And thank you so much. And I guess that's it for today. Thank you, everyone. Thanks.